I just missed it. Okay, so that the topic what we are going to discuss about today, that is equilibrium, static equilibrium of moments. And before that, I told you that what is equilibrium. Equilibrium is when the bodies have no net force or they have no resultant moment. Moment can also be named as torque. Okay, so we call that bodies at equilibrium or bodies in equilibrium. So here we go. There is, when a body is at rest, according to Newton's law, either the body is at rest or moving with uniform velocity, then it is said to be in equilibrium. So when a body is at rest, it is called its static equilibrium, and when a body moves, it is called its dynamic equilibrium here. Okay, so we will talk about the static equilibrium. Static equilibrium of two types. I have explained these two one by one. One of them is static equilibrium of forces, right? That we deal with Newton's first law of motion, that either a body will be at rest or yeah, body will be at rest if there would be no resultant force acting on it. And then dynamic equilibrium is basically related to movements. Sorry, that is related to the motion of the body. We have studied about that. If a body is in equilibrium, it will move with a constant velocity. And then I just put one equation here, one statement here. A body must be at rest without rotation. This rotation topic is actually the moment what we are going to discuss today. So when I talk about the static equilibrium, this is actually the turning effect of force, and turning effect of force is having a sequence. The best sequence is right after vectors. We must go to the static equilibrium of forces because resolving is there, and then we have to know about static equilibrium of moments, and it is a good sequence. But here I have just put it after the forces. So moment is the product of force and perpendicular distance of the line of force from the pivot. So when we talk about that, that moment is equals to product of force and perpendicular distance. This is the distance d. This is the formula for the moment, and its unit is Newton second. Okay, but from this statement or from this definition, there are something, some new points to be learned, and these points are, although they are not new, people have new, or you people knew these points in your IGCSE and previous level. Perpendicular distance and line of force, I have to explain. So line of force is basically that line through which all the forces pass through, or through which force pass through. For example, as I explained you, that if there is a body, this is a rod, and this is the point where I'm going to apply the force with the help of a rod or with the help of a rope. Then this is acting at all these point number 2, 3, 4, 5, 6. Along with that, if I'm going to apply the force from the external, from backward, from back sides, this will behave like the same as this is acted upon from the front if the line of force is not changed. So pivot or axis of rotation is basically the point or the line about which the body rotates. If it is a simple point, it is called pivot. For example, if I have a rod, okay, and this is it is fixed with the nail at a point, and then I'm going to apply a force over here, just like your arm of the minute and second arm of your clock. So they basically, they are pivoted on the center. But axis of rotation is something like axis about which this body rotates. This is the line about which the body rotates. So here, its example is just like a trap door or the door. These are the hinges, and these hinges are actually the axis of rotation, and you are applying the force, and that it rotates. Then we will talk about the moment arm. Moment arm is actually, this is very interesting term. Moment arm is the perpendicular distance between the line of force and pivot or axis of rotation. So here I have different examples. For that one I have explained it. So this is the rod, it is pivoted over here, it is point P, pivot, and here I'm going to apply some force, and that force is applied along this green line. This is, that's why I put that this is a line of force. And if I measure the perpendicular distance between pivot and line of force, that is its moment arm, right? Is it clear to you? It is its moment arm and it is represented by D. Okay, so moment arm is always the perpendicular distance from line of force to the pivot. So in your moment or in your yes, static equilibrium topic, you must hunt the perpendicular distance. What you have to do? You have to find out the perpendicular distance or moment arm. Is this clear to you?
Yes, clear.
Okay. Now we will talk about another interesting point, that what types of movement are there? What are the types of movement? There are two types of movement, either clockwise or anti-clockwise. So when the movement is clockwise, it would cause the body to rotate in a clockwise direction. And if the movement is anti-clockwise, it will cause to rotate a body in anti-clockwise direction. Is it?
Yes,
Is it clear to you? So
it's
the
clear.
moment which is clockwise, it is considered as negative, and moment which is anti-clockwise, it is considered as positive. This is very interesting, that clockwise and anti-clockwise moment, actually they are represented by a grip rule. For example, if there is a body and you are going to rotate it about the axis of rotation, let's say here is the axis of rotation, and that body is rotating in this way, it means you are applying the force here. This is the force, is the axis of rotation. Then you have to follow grip rule, right hand grip rule. So when we are going to apply right hand grip rule, it would cause the turning of this body in clockwise direction, and due to that, the movement will be in the direction of your thumb. Movement will be here along the axle. Remember this thing. This is the direction of the movement. But in the same way, if the body is under that force or under a force which is causing to rotate it in anti-clockwise or anti-clockwise rotation, then again you will grasp this, yani you will apply your uh, grip on the body, like this is the curling of finger. This is what? This is curling of finger. Okay, this is curling of finger. So you will curl, this is curling of finger, this one. So curling of finger is if it is anti-clockwise, what would be the thumb pointing? Thumb will be pointing upward, isn't it? That is why it is called as positive. So similarly, we just, if we have the vertical motion or vertical direction of rotation, if the body is having clockwise, sorry, anti-clockwise rotation, then anti-clockwise rotation will give you an inward thumb pointing. That means it is negative. Okay. And if, oh, sorry, that means it is positive. And if you have anti-clockwise rotation and that will be pointing outward, that means this is your positive, right? So this is the game behind it. Is it clear to you? So till this point, I have just explained you the moment, but not the principle of moment. Wait, tell me something. Principle of movement is something different. When more than one movements are applied, then we follow principle of movement. Okay, when we apply or when there are more than one movements, then principle of movement is applied. Is it clear to you?
Yes,
But when there is a single movement, then we apply just movement F into D. But here, because it is principle is there, so for a body to be in equilibrium, sum of clockwise movements must be equal to sum of anti-clockwise movements. This is called principle of moments. So I believe that by definition it is very simple by statement, but when we apply it, it has some sort of complications. Okay, that sum of clockwise movements equals to sum of anti-clockwise movements. Very good. So here we have, for example, if a rod is there and if that rod is pivoted from this point, this is that black point was its actually pivot point here, and you are applying different forces. The forces are, I have mentioned different forces. These two green forces are uh, F1 and F2, right? This is actually F1 and F2. Okay, these two, they are acting downward. These two black forces on the right hand side of the pivot, they are actually P3 and P4. Okay, is it clear to all, to both of you? I mean, to you? I can imagine that there would be more than one students in my class. That's why I
It's just me.
used to ask you that, is it clear to all of you? Okay. Now, if you see these black forces, F3 and F4, they are providing you anti-clockwise movement. Similarly, it is providing you anti-clockwise movement. But these green forces, they are providing you which type of motion? Clockwise, is it? So, according to principle of movement, sum of clockwise movements equals to sum of anti-clockwise movements. So, F1, yeah, the main problem here with the students is when they are going to measure the distance, that distance is from the pivot. For example, here is your F1. Okay, for example, here is your F1, and your D1 will be the distance from pivot to that point. So that is this distance D1, right? Is it clear to you?
Yes.
Okay, but if yani product of F1 and D1 is your moment number one. In the same way, there is another force F2, and that F2 is acting from a distance D2 from the pivot. Here is pivot, and this is that distance, so it is D2, and you will say that F2 D2 is your moment number two, isn't it?
Yes.
In the same way, this is F3, then F3, D3. D3 is the distance from this pivot point to that line of force. So that is your moment 3. Okay. And so on. That is F4 and D4. F4 times D4. That is your moment force, moment number 4. These are all the moments. And when you apply sum of clockwise and anti-clockwise, you will simply say that sum of clockwise moments is equals to sum of anti-clockwise moments. So that will give you a situation here that if I have sum of clockwise moments and sum of anti-clockwise moments, they must put in the equation that F1 D1 plus F2 D2, that must be equals to F3 D3 plus F4 D4, isn't it? Do you see that? Is this diagram clear to you? Yeah, yeah. Is that diagram clear to you?
Yes, it is.
Okay. Now, actually, the questions are not that much easy. What I have explained it normally. Once the theory would be done, then I will move to the topical questions, and then you will have more developed concept. Okay, so yes, here are those horribles. Okay, right after that, let's talk about couple of torque. Torque or couple of moment is the same, or couple moment. When there are two equal and opposite forces acting on a body, those two forces will cause to rotate the body in the same direction. That is called couple torque or couple of the forces. Couple torque of the forces, right? So when two equal and opposite forces which cause the movement in the same direction, that is called your couple force. Here, just see this diagram. There is your F1 and F2, and this is the pivot at the center. And both of these forces are acting at point A and B, and here is point O. So F1 is acting at point A at a distance OA. That is the distance OA from pivot, and B is acting downward, although force is opposite, but it is causing the rotation in the same direction. That means that this F2 is having the moment arm OB. Now, if I say that both the torques are both the moments are clockwise, isn't it? Are they? Both are clockwise, na?
Yes.
So when both are clockwise, that the total moment can be sum of both of these moments. What will be the total moment? Total moment is actually sum of these two, F1 OA plus F2 OB. So as F1 and F2 are equal, this is the condition for the moment. This is very, very, very important. Two equal and opposite forces. Just mind it. Okay? Please recall this statement. When two equal and opposite forces acting on a body, the forces must be equal. If the forces are not equal, they will not be able to produce a moment. Okay? Is it clear to you?
Yes.
Okay. So it means F1 and F2 are same. So I just keep it F and F times OA. If I keep it F times OA and plus F times OB, actually in between, if you see, you can just replace this, that this OA can be added with OB because F is taken out common. When F is taken out common, your I mean your equation is left behind with what? Yes, OA plus OB. So go back to the diagram. What is this OA and OB? See that OA plus OB is equals to what? OA and OB is equals to what?
Yes. And
A
OB
to
is
B.
yeah.
Yes, OA plus OB. Isn't it equal to AB? I mean, distance from O to A and distance from O to B. If I add them together, what I get? Yeah, is it clear to you? Your response
Yes.
is very slow. Do you get it?
Yes.
So that is AB. So I can define that couple torque is the product of couple torque is the product of any one of the forces and any one of the couple forces and perpendicular distance between the forces and perpendicular distance between the forces. Is this statement clear to you now?
Yes.
Surely clear.
Yeah. Yes. Yes.
Okay. So here we go. These are the examples of couple. For example, if F is a force which is applicable on this edge of this circular wheel, and F is the force which is acting on the other edge of the circular wheel. Both of them are trying to rotate this into anti-clockwise direction, sorry, clockwise direction, isn't it? And what is the perpendicular distance between them? The diameter of that. This is R, this is R. So I can say that moment is equals to what? Moment is equals to F into 2 times of R. Is it clear to you?
Yes, yes.
Okay, in the same way, if this is a hexagon, I mean octagon maybe, a decagon, I don't know. But all these positions, if you want to find the moment here, if there would be more forces acting on this body at all the edges, there would be more couple. And when there will be more couple, actually, you will get bigger torque or bigger moment. That is why, yes. Why I was explaining this. You know, there are, when you are going to open a nut or a bolt, there are one of them is flat, right? Then the other type is cross ones, like this. Here we are producing two movements, right? And if we have a nut like sorry hexagonal, or let's say this one, right? If you are going to open it from a spanner, then you have how many movements or how many couples. If spanner will basically hold it, definitely spanner have to hold it from here, is it?
Yes.
So the spanner is applying the force on these two edges and these two edges. So this will be one moment, this will be other, this will be one moment, this will be other. In the same way, if you are going to produce this type of nut or bolt, in which there are 1, 2, 3, 4, 5, 6, 7, 8 sides, then it is quite easy with the help of a spanner or a socket. Actually, it is not opened with the spanner. Like a socket is used to fix it at the top and then to rotate it. So that all is the game of movements. Okay, is it clear to you?
Yes.
Is it clear?
Yes.
Okay, now there are some cases of the movement. So I believe that it will help you out to understand. So let me just stop it and to start it.